with my colleague and co-presenter Kadupatil, who is also a senior architect in Verolt Technologies. So we are here to discuss the AUTOSARs role in software-defined vehicle, and this is really a privilege for us to be here today and discuss this topic. So from yesterday we have seen lots of topic for the AUTOSAR for SDV or AUTOSARs roles in SDV. Though we will like to take you through some of the topics here. So I will just quickly go through the I will just quickly go through the agenda. So we'll start with the evolution of automotive electronics. After that, the characteristics of SDV. Then some of the challenges in SDV, for example, variant handling, authorized remote diagnostics, safety, security, and then we'll just try to describe about a new concept which is emerging vehicle API, and then we'll move to the closure part of this with the AUTOSAR for SDV. Okay, so the automotive electronics started here with the hardware-based era or hardware-enabled era, we can say. So in this era, mainly the features and functions are based on the hardware. So manufacturers used to add the hardware to enable the features. So let's take an example of a power with a switch, where the motors can roll up and roll down the windows. DC motors used to roll up and roll down the windows. So after that we move to the software-based era, and this is formally transition to the EE architecture, where the automotive world is actually started to update the software to give the feature or update the feature. So here we can take an example of a ADAS system where you can enable or disable the different features on the same hardware or same ECU. So in the ADAS ECU you can have a low content features and a high content feature or full content feature in the ECU with the same hardware. However, so with this current situation, now these are some emerging trends in the automotive industry. So the trends are mainly the personalization, user experience, integration with smart city infrastructure, increased connectivity and autonomy, and sustainability in the development. So these these trends, the concept is emerging, which is SDV. So this is what we are mainly talking about from yesterday. So SDV is nothing but a vehicle which is driven by software, or features of the vehicle which are driven by software. So with this we move to the next slide. So I will just try to explain these characteristics of SDV. So first we'll take the first characteristic, that is feature and functions are primarily enabled through software. So this is the same data which I have just said. So mainly the features are driven by the software. Okay. Then features are completely decoupled from the hardware and firmware. So though we are saying we are using AUTOSAR and we are developing a software which is independent or abstracted from the lower layer, still when we start in the starting of the development, we first think about the hardware. This is the same point which is being touched by some of the presenters earlier also. So, but with the SDV, this should not be a case. So with the SDV, software should be totally decoupled from the hardware. And with this, we can do the simultaneous development on the digital side as well as hardware-based side. So the time to market will be less. With this, we'll go to the last, that is remote execution of the cloud-based software feature in real time. So here with SDV, a concept can be possible that we can actually run some of the software on the cloud side or at the server side. So currently whatever the feature or whatever the software we have, that is only implemented or that is only structure or kept at the vehicle. So with the SDV, we are thinking about that there are some applications or some part of the code which can be executable on the cloud side, but will provide the feature on the vehicle side. So when we talk about the SDV, we are talking about seamless connectivity. So this seamless connectivity, the user experience shall remain the same. There will be no hurdle on the user side, but we shall reduce the memory footprint on vehicle and basically reduce the computing efforts also on the vehicle side. So let's move to this. So these are some challenges in the SDV from our perspective. So variant handling and feature coding, authorized remote diagnostic, safety and security, hardware and software integration, as this is a new and emerging concept. So creating a platform will be a challenge. So that is where the hardware and software integration comes into the picture, and continuous development and deployment as the features will go on the what we can say feature on demand cases. Okay, so we will like to touch upon some of the challenges here. So let's start with the variant coding and variant handling. So what is variant coding? It's nothing but aligning a ECU or coding a ECU to other some of the functions or one of the variant, and managing this variant is variant handling. So in the current trend or most of the current vehicles which are here, we can say that the static variant coding is there or is applicable. So what is static variant coding is basically this variant coding is done in a very controlled environment of a manufacturer, where a manufacturer adds their variant codes to the vehicle at the EOL side of the line of production or at the service station. But when we think about the SDV, there will be different features there, and for this different feature, we may need a concept of dynamic variant coding that will enable the variant coding on the go or after the sale. Okay. So we'll move to the next slide. Yeah, so this is, I'll continue with the same point. This is how the current picture looks like, that there are the OEMs, and OEMs have different vehicles, and with the different vehicles, different variants are there. So this is very manufacturer-based environment, and a manufacturer can decide which feature can go into which vehicle and which vehicles, which variant. But if we are thinking about a full-scale SDV, this picture may look like this. So there can be a third-party feature pool or a common feature pool where a supplier or service provider can develop the app and they can release the app. Okay, but with this we should adhere to the variants also. So whatever the features are released by the third-party developer, those should all seamlessly work on each OEM's, each vehicles, each variant. So that would be a difficult task to achieve. Okay. So that they, so due to this, in SDV, the variant handling or variant coding will be a challenge from our perspective. So currently, AUTOSAR is providing some of the solutions. It's not that AUTOSAR is not providing. Those are good for today's era or today's vehicle. So from the AUTOSAR side, we have some things like post-build variant context, altering the execution path after predefined configuration, and variant-based diagnostics and debugging like this. But these solutions will not be able to achieve the complexity, or they will not be able to succeed to give us the proper solution, what the complexity or scalability we are talking about with the SDV features. So with this, I would like to hand over the presentation to my colleague.
Yeah. Thank you, Verolt. Hello all, good evening. I'm Kadupatil. So yes, in previous slides, Verolt has walked through us is what is SDV, how electronics, automotive electronics is evolved, and then challenges with SDV, current challenges. So next, here it's the authorized remote diagnostics. Means what do you mean by remote diagnostics? If means vehicle is at remote place, nowadays means OEMs are providing this service. So remotely they are accessing the data through the vehicle, and they are trying to diagnose it, and if there is any minor problem they are trying to correct it. If there is any major problem, they are suggesting to driver to take it to garage vehicle. So in the authorized remote diagnostics, definitely in with SDV there is a large number of data which is incoming and outgoing from the vehicle and to the vehicle. So because of this, there is a need of safety and security we need to apply here. So here in authorized diagnostics, we have to apply the security, cyber security it's a secure diagnostic concept comes in picture, and we have to make it more secure so that OEM or the service station, they can access it remotely, they can check that data and perform the further operations on the problems or occurred in the vehicle. So here there are some existing challenges: data privacy and security, and the integration with the current existing environment, cost of deployment. These are the current challenges in front of authorized remote diagnostics when we are going to implement it. So there are few. Here you can see the OBD. Onboard diagnostics is there through the network or cloud. Data is continuously means through the vehicle or the network. We are sending to the cloud and it is stored over there. So using the AI, we can analyze it and then process that data. And here user or the OEM or the service center, they can access it, they can check it using the web app or the mobile apps and indicate to the driver. So this is the complete concept here. Next, in current in AUTOSAR, that diagnostic stack is already there in Classic platform, and it is already implemented. But yeah, along with this, we have to in the UDS protocol is already available there. We have to make that data secure, and for this protocol, this stack will help us. UDS stack will help us. And for again, there is one more concept: SOVD, service oriented vehicle diagnostics. That concept will provide a single API to diagnose the vehicle and for the communication purpose as well. So this will help the development as well as the OEM and at the service center as well. So next, safety. Next challenge is about the safety. All of us we know about the functional safety standard ISO 26262. So this is applicable to complete vehicle. There are many features, number of features available in vehicle. So where features are classified as from SL A to SL D level, and those are then safety is applicable accordingly. So here when we are thinking about the SDV, so because of huge data, so which is incoming and outgoing from the vehicle and to the vehicle, so because of that there may be a risk or risk of hazards. So we have to identify it, and how to mitigate those risks, we need to check it. So with the existing AUTOSAR, the end-to-end protection is also available here. So with this we can add or change the requirement and make that stack more robust, and yes, and we can handle those errors which can occur. So this is about safety for the SDV. Next challenge is about security. So yes, here as data, we need to play with data, which is very crucial for us. And for that, we are storing that data over the cloud, and from cloud to again vehicle, we are communicating continuously. So here there might be a threat or hackers or phishing activities may happen. Due to this, there may be a change in the final decisions of the ADAS algorithms. So that is very dangerous while driving the vehicle. So for this we need to take care about it, and with existing stack, yes, it is there, but we have to change the requirements and add also those in AUTOSAR. So yes, and there are few things like cryptography. Then here transport layer security, remote code execution. So using this we can add the more safety in this. So this is also we can take care with respect to SDV. So vehicle APIs. If you think means yes, when AUTOSAR is there, means classic as well as adaptive platform, then when it is limited to vehicle. So as you know, classic platform is already proven and adaptive its development is done, deployment is ongoing. So here if you see, vehicle is continuously connecting to means in SDV. The concept of SDV is that V2X, vehicle to anything. In previous sessions as well, many presenter or in many presentations they talk about this V2X concept. So vehicle to vehicle, vehicle to pedestrian, vehicle to OEM, again vehicle to cloud. So these are there, and for this there should be a standardized API should be available for the vehicle as well as this the infrastructure and everything. So due to this, vehicle can connect easily with the outside world, and here safety also important, because when we are connecting to outside world, there might be a chance there should be data manipulation may happen. So this vehicle APIs are important to get standardized. Yes. So in this slide, you can see there are three pillars. Those are important for SDV. First is classic platform, second is adaptive platform, third is digital platform. And their height shows the maturity of software currently. So classic platform is bit matured with respect to adaptive, and the digital era means with respect to SDV only. And here, so by modifying few things in the classic platform as well as adaptive and digital, so we can make it more robust so that SDV framework can be more sustainable. So then after this it will look like this, and these are the advantages of AUTOSAR: the maintainability, scalability, modularity. So using these advantages with adaptive as well as digital, we can make our SDV more robust. So this is all about AUTOSAR roles in software defined vehicles. Thank you all. Thanks for your attention. Any questions?